Welcome, everyone. I hope you enjoyed the sandwiches in the first half of the day already. I see quite a few of you are back from Jos talks this morning. Who has attended that talk? Oh, quite a few. Okay, so I unfortunately have to still do a bit of introduction because of the recording and people on the interwebs that would want to watch this stuff. My name is Oliver Drotbohm. I've been working in the Spring open source engineering team for more than 15 years now. Primarily done the data projects, so all the CRUD repository stuff. Went through basically my hands and the team that I built around this topic. Most recently, actually for 5-6 years now even, I work on the Spring Modulith project, and in this session I'm going to show you a bit about what it is, of course, and most importantly, a few things that might not everyone who's just regularly upgrading might have noticed, and I give you an outlook on what we're going to ship in the 2.0 version based on Spring Boot 4 in November. By a show of hands, who of you is using Spring Modulith already? Okay, that's not as many as I expected, but it's great. Not because I'm kind of I'm pessimistic about it, but because if you go to a talk in what's new in yada yada yada, then I would have assumed you're likely at least a bit familiar with it. But then, before we go into this, we start with what is Spring Modulith. And I promise this is going to be the only slide that looks like this, like with the book page of text on it. From the project homepage, it says that Spring Modulith allows developers to build well-structured Spring Boot applications and guides them in finding and working with application modules driven by the domain. So there's some kind of modularity thing going on. It supports the verification of such modular arrangements, testing individual modules, integrating them in eventually consistent way. Take a breath. Observing the application's behavior on the module level and creating documentation snippets based on the arrangement created. So I've highlighted the things that might be the things that stick out and that are most interested. We're not going to have the time to look at all of them, unfortunately, and although there's a bit of stuff, for example, in the observability area, but it's even for the advanced thing, it's a bit more too advanced, right? In the interest of time. Let's just start, right? I'm here, so I need to go this way. So, let's get off this mixture here. Where did I leave this? I should have closed a few tabs before. I don't know. The usual thing. You prepare stuff and then you keep it lying around. So what you see here is just an example project that I have that's Arc Evidence Spring, just a sample project on GitHub that you find. And it basically has a couple of commits taking you step by step in introducing certain Spring Modulith features. We're not going to do that, actually. I just want to basically show you the final state of the thing, and we're going to pick out a couple of interesting bits, I think. So the first thing that if you've seen the talk this morning, it's not going to be terribly surprising. It's a standard Spring Boot application that has an application class in its root. I can probably scale that down a bit. Let's try this. The fundamental idea is that we now inspect your package arrangement by default and assume that you have put in thought into this and basically create an application module model from that. And the way that we do that is usually by running application tests. And let me just take this one here. Not the application test, but there's a modularity test here. That's pretty typical for a Spring Modulith project. We instantiate an application module instance pointing it to the Spring Boot application class, and we can then, for one, print the model out, and we can call verify on it, right? So let's see what we got here. What you see is that we actually picked up 3 application modules. That's the hash thing in front of it. It's from the immediate sub-packages of the base package, right? So that's kind of the default convention. There's a lot of ways to customize like what we detect as modules. If you're interested in that, go watch the recording of Jos talks this morning. He has like plenty of details for that. We also inspect the application code and can find out about the dependencies that you've quote unquote put there by accident, right? So we don't require you to start with a big application architecture description of something. We basically again, assume you know what you're doing and derive the dependencies of the modules from that. So in this case here, we see the inventory has a direct module dependency on the module orders. Order in turn depends on customers, so there's some kind of relationship forming, like a tree, right? If you know what you're doing, then that's going to be a tree. If you don't, we actually pick that up. We find out about, like, when we find circular dependencies, we kind of reject those in, let's say, this call here to verify. I'm going to come back to that and what exactly this is verifying later on again. So zooming out a bit again, what we basically provide you with is means to put verticals in your code base, right? So instead of structuring your code in very horizontally ordered, or maybe even hexagonal or onion or what have you, we suggest to start on the first level with the functional decomposition of your application. If you want to know more about that discussion, there's going to be a talk, I think, in 4:50 or something later this afternoon, where I talk about more of what the motivation behind that is and why we think onion and hex should be basically rather put as a second level decomposition strategy. Right, so you get the means to actually define those boundaries. We verify that you adhere to the self-implied boundaries, and we then provide a bit of technical integration for you to leverage that decomposition. For example, you can run tests by vertical slice, basically. Right? So you're probably familiar with the Spring Boot testing annotations. You have add Spring Boot test. Fine, that bootstraps the entire application. And then there's variants of that, like the add data JPA test, add web MVC test, which carve out a horizontal layer from the application. And they do that because the only information that Spring Boot in itself can adhere to is things like add controller, add service, add repository, which are inherently layer-oriented, right? You can also think of them as hexagonal adapters or what have you, but it's a technical decomposition strategy, and that's how Spring Boot actually attaches to that information. But now that we've kind of given you the tool to tell us about your verticals, we can actually use that information to then instead of like only bootstrapping the beans, the Spring Beans of a certain layer, we can bootstrap all the beans of a certain vertical, right? And that shows, and that's basically what the test here does. It's not really doing anything real. Is that the log shows this even better. I can probably just go here. All right, so when we start the test, you see we started in standalone mode, so we only bootstrap that single module. You get the information printed out, which module gets started, which beans that includes. And then the magic happens here, where we basically tweak Spring Boot to only scan the example.inventory package and only apply auto configuration to that, entity scanning to that, yada, 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 right? So yeah, that's it. There is like it, of course, and what the test here is trying to assert is that the order management component is not even bootstrapped, right? Although we have a technical like type dependency into the other package, there's no bean for that included in the test run. That's kind of the thing, right? It of course gets a bit more complicated when you have like modules depending on other modules. If you're interested in that discussion, there's been a deep dive workshop on Tuesday. The recording is already up. That's kind of the thing, the fundamental thing in a nutshell. One other thing is the documentation support. I've used another project here, the Spring REST bugs thing that is a slightly more complex application that I use to showcase a variety of Spring technologies, and that has the same modularity testing, and there is a new documenter, write documentation thing in there. that gets the modules instance handed that we've just created. You see that looks almost entirely the same. And when you run this test, what happens is that you, in the target folder, you're going to find a Spring Modulith docs thing that has an ASCII doctor and plant UML documents generated. By default, they generate C4 diagrams from Simon Brown's C4 model. And also, it's kind of interesting, I think, these application module canvases, which are kind of like a superficial description of the surface of the module, and those like pick up on very interesting things in the, or a lot of interesting things in the. Is that the right one? In the module, right? So we find out like what's the API, and then we pull out the Java doc, for example, to basically pull this up, right? If you want to know what the module can do on its surface, you can just use these generated snippets, and with the major advantage of that stuff being correct, as in sync with the code base, right? No manual updates, what have you. All right. So one of the things that have been a relatively recent addition. So I'm going to talk about basically 3 generations. One, the latest, or the current one is 1.4. We had a lot of like interesting, as I think, new features in 1.3. That's why I included some of those. That was from 1.3 was from November last year. 1.4 is from May this year, and 2.0 is going to be is going to be released in November this year. So one of the biggest additions in 1.3 was the ability to have nested application modules. So if you think of the arrangement that we kind of allow you to produce, you get like a module, right? So a logical unit, and that unit has an explicit surface, right? So we allow you to kind of deliberately decide which types are exposed to other modules or not, with the implication that other modules can only depend on that very surface, right? And it cannot depend on anything that's internal. So, and that's kind of a common theme between different modularity approaches like OSGI, the Java Platform Module System. What the other module systems lack is the ability to nest modules inside modules, because if you have this kind of this darker green area here on the left, that could still be a mess, and you can argue that's a feature, because right, what happens in the module stays in the module, right? So it's kind of like you all know that not all parts of your system are equally well designed, and that's totally fine. Right? But if you, let's say, want to go ahead and within that module really want to like get a bit more order into the arrangement, you can, as of version 1.3, create nested application modules that in turn then also have an API, so that the following access rules apply. For one, module A internals can, of course, depend on types in the nested modules API. Module B, or code in module B, cannot, right? Because it's like the nested module is fully contained in the outside module. So if you want to expose API from the nested modules, you would have to do so through some component in the module A's API, and then connect that to some degree with the API of the nested module. What's also not allowed is that module A internals depend on the internals of module B, of the nested module, and sibling modules must also not like reach out to others' internals. Like the upper nested module would be allowed to depend on the API of the lower nested module. I probably should have named them differently. But you're not allowed to access the internals again, right? There's a tiny example I have prepared. It's still not yet fully pushed to the repo of the Spring Modulith project, but I have an example down here. Let me just, let's close all of them. Spring REST box is gone. There we go. So what you see here is, you've seen I've worked on this until 30 minutes ago. What you see here is exactly what's going on, right? Inside out and outside in. I can tell you about the reason why I named them that way. at some point. But you have like, let's say, some client code here, like just some code that calls something internal, right? There's some internal abstraction we want to use. Let's say some adapter to some payment API or something that we want to hide behind an interface. And we use this inside-out provider here. That's the interface that's abstracting that code. And we want to have the provider impl here. That probably should implement IO provider, right? Not necessarily important for that. Implements, my gosh. It's not necessarily important for the example, but that's kind of the work. That's why it's saying inside out, right? We reach out from the inside to the outside of the application module, right? So from here to there, right? From the nested one to this thing. So this works fine, and there's no need for. I mean, what I'm doing here is I mark the package as an application module. So whenever you add an add application module annotation to one of the nested packages, this package becomes a nested modules base package, right? And we can, to just show you what the arrangement looks like for now, I can again do the same thing you've seen before. We now have 1, 2, 3, 4, 5 modules. That's because we have the inside-out module, we have the nested module, we have the outside-in, nested, and sibling. Right? These are the kind of the nested modules here. Right? And the one thing, let me just go here and say which classes I have to tweak to invalid submodule reference. Yeah, okay. I have to tweak to show you the effect of that stuff. So what you've already also seen here is we still do the verify thing, right? So as of now, everything is just fine. We're good, right? I have a similar arrangement in the outside-in variant, which is structured like this. In this case, I have moved the provider interface into a nested package. And why did I do that, or what's kind of the use case here? This thing here has the disadvantage that I can live with that, and I don't necessarily even need nested to be a submodule. But this thing here, because it needs to be public, right? This is a public interface to be visible to this thing. And this being an application module-based package, IO provider would become a part of the inside-out modules API, which is something we would want to avoid, right? So why not just move that type into a nested package, and then actually declare that, and let me zoom out again, an application module, and then have this thing, the outside-in provider implementation, actually implement that interface, right? So with that, these two packages are basically hidden from inside out, but can still relate to each other, Yeah. Something you probably that I should have mentioned here in the output is that once you start creating these submodules, you will see that they are essentially carved out from the owning modules package structure, right? So example outside in is the base package for this one here, and for the two nested modules, we carve out the packages, the base packages from the class analysis and whatnot. We will see what effect that has in a second. And just to show you a couple of potential violations that we could introduce. The one I've already hit here. So this is the scenario where one module tries to reach out to an internal of a submodule of another module, right? So it's getting pretty oh boy. We're trying to prevent that. And that fails with invalid submodule reference from module inside out to module outside in. .nested via yada yada yada. So you get pretty precise information like what's going wrong here, right? So we catch those. We also catch what was the other thing? Do I have any things here? Nope. Outside in has a client as well. There's probably so outside in provider impl. That's kind of the owning module reaching into internals of a submodule. We can probably just remove that. Does that work? I think I renamed them at some point. Yeah. Huh? Nope. Okay, that's kind of like already protected by the compiler, which is fine. But if you had this thing made public by accident, it should actually break as well, right? So it says outside in depends on non-exposed type of outside in nested, yada, 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 within module outside in nested. You see the message. And the final one, I think, is in here where we showcase that a nested module cannot actually access a siblings module's internals. That's what we're trying to reference here, the sibling impl thing. And then that would break as well. Did I undo this? Probably not. Right, so it's still breaking, right? So outside in nested depends on non-exposed type of outside in sibling, yada, 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 right? An interesting question, let me just undo the problematic things here. An interesting question happens, that's why I showed you the testing thing, is what does that do to our integration tests, right? And the simple thing to start from is that like for our nested application modules, this is again just fine, right? We do the same thing as we did before, right? We find our OI nested test residing in the outside in nested module, which is a submodule of whatever. But we basically again carve out that tree from the class path and bootstrap that, and then Spring Boot does its magic again, right? If we start an integration test for the parent module, things become a bit more complicated. Because what happens by default is, as I said, the submodules are kind of carved out of the class space. They're actually, they need to be, so what we actually run is only the parent module, not including the child modules, right? So we can, that still works because we mock the OI provider. If we don't mock that, we basically get that the client's reference to the OI provider, right? So this thing here depends on the API of the nested module, and that doesn't work unless we actually explicitly provide that. How do you work around this? There is a bootstrap mode, all dependencies. That then basically just selects the modules that the module to be started actually needs, and then we can run this. Right, so that's green again. Right, probably a lot to digest. At some point I have to prepare an example with better names here, but I just wanted to give you a brief impression of what that looks like. Most important things is you can just define nested application modules with the add application module annotation. That also is reflected if you're using a custom application module detection strategy. Then you basically just return the sub package as a base package for the modules, and then you're good. All right. So we have 27 minutes to go. Named interfaces. Has any one of you ever used named interfaces with their Spring Modulith applications? Oh, only a few. So what is a named interface in the first place? I admit it's not the most creative naming. So far, what we've seen is that application modules have like two interfaces. Interfaces not in the Java sense, but in the logical sense, right? One is the provided interface, the functionality that you provide, basically all the types, all the public types in the module's base package, of course customizable, but everything that a module, quote unquote, exposes, right? The required interface is basically everything that it depends on. If you think of like Spring classes or Spring components, they follow the same model here, right? So the provided interface is all the public methods of the class. The required interface is all the constructor arguments, right? That's how the dependency injection then basically puts together the components. So that's fine, and for most use cases, that's just enough, right? There are use cases when you want to be more specific about the definition of a module's provided interface. Let's say you have a module that has an API, a general one, but also has certain types that are deliberately designed to extend the module, right? Like a plugin interface or something like that. Then you can go ahead and, using Spring Modulith, define two of these UML ports things on the provided interface side. There's like the required interface side is broken, unfortunately. That's like also like this little C was supposed to be there, right? So you can define dedicated sets of types that form a named interface and give them a name. That's why they're called named interface. Interestingly enough, the implicit one, where are we going? That little guy fell asleep. The one up here, the implicit one, I'm particularly proud of the unnamed named interface. Right? That's kind of, naming is hard sometimes. That's why I leave it to you to give the names. Just kidding. So we're going to see how we actually achieve that. That's something that's been there in Modulith, like I think since its inception. Really, the term is coming from a code quality tool that I've used quite a lot, the Sonograph toolkit, and of course, the UML calls these things ports. I didn't want to go with the ports term because that's very associated with the hexagonal architecture thing, but it's something different here. The thing is that once you define these individual named interfaces, you can also explicitly reference them when you're using explicit application module references. Right? So when you say add application module, allowed dependencies, my module, would be like the upper case, right? The case we want full access to the module, but if you only want to give access to a certain subset of types, then my module : API or whatever you name them, right? So yeah, let me give you the demo for that. For that, we're going to jump back into Spring REST-Bugs. It's a very simple. It doesn't really make much sense here. The only thing that I want to, in terms of like it, adding the named interface there's no need for that in any case. But what I'm doing here is the primary API thing that's exposed here is the payment service. It's a Spring Bean that has a couple of methods, it actually only exposes a subset of types from the package, from the entire package. You see there's like credit card payment, there's a credit card number, payment itself, receipt, and order. It doesn't actually expose credit card, right? But credit card is still like it's like an aggregate in this case, but it's part of the API, but it's not really necessary to be exposed here. So let me just run the modularity test again. This one here. Oh, we have to comment in system out. See what it looks like in the first place before we even start working with named interfaces. Unless you actually start adding named interfaces explicitly, we're not even listing them in the output because everything that's in the package is just part of the named interface. So if I go ahead now and basically do this, add named interface. Let's say we call this API. So I did an example. The output changes to the following, and you get the named interfaces listed. And you see as the infamous unnamed named interface. And in this case, we add the unnamed named interface of the module stays the same. So you still have the option to say, okay, you are allowed to reach into everything, but the API named interface is now derived from the payment service, right? So payment service actually is the last thing to be listed here. And you probably ask the question, okay, why is it that we pull in all these types here? In this case, right? And that's a difference between the version 1.4 and the upcoming 2.0, right? In previous in the current generation, we only applied the named interface or the type, only the type that was really annotated with @named interface API was basically included. So you annotate the types that you want to include into that named interface. However, that in this case, to achieve what we actually want to achieve, which is like use all the types that are declared here, we would have to go and annotate credit card number, order, credit card payment, right? This is getting tedious. So what 2.0 does, it automatically propagates into the type space, and it looks at all the return types of all public methods and all the parameter types and all the public constructor arguments, these kind of things. So with this arrangement up here, without any further detail, you would basically end up with these 6 types exposed. If you watch the demo output closely, credit card still appeared in there, right? And that's why we transitively apply that. That's the reason for that is that we transitively apply that, and I think the credit card payment has the credit card associated with its type in some method. I think you can, on the credit card payment, you say get credit card, and then so it's part of the API, so we pull that in, right? Just for that, if people look at the slide later on, then there's no credit card appearing here, so that's why I basically framed it that way. All right. Next, change-aware test execution. Who's using JUnit? Okay. Now you. There were people that didn't raise their hands, and I'm curious now. Like, are you just brave enough to phrase it politely? I don't know. Excuse me? Spock? Oh yeah, okay. I'm sorry. Yeah, of course. There are other test frameworks except JUnit. The thing is, I have a colleague who works on JUnit, so that's why I'm best friends with JUnit. One thing that we've added, and that's actually been a community contribution for the 1.3 release too, is that we can actually do interesting things with your test execution. So when you build up a vertical slice module structure with Modulith, you end up with something like this, a directed acyclic graph of module dependencies. Right? You might, by accident, introduce a cycle, but then we're going to make you aware of that, and you hopefully fix that, what have you. Why is that helpful? Right? Like, for one, cyclic dependencies mean the members of the cycle can only be understood as one. If you change one of them, you risk breaking the others. And that's not the case if your modules form that directed acyclic graph, right? Which means that when we change something in A, what do we need to change? What do we need to test? Everything. Why do we need to test everything? No. A is depending on C and B. So C, by definition, cannot be broken because it's entirely unaffected of the changes, right? So we only need to test A. The problem is that without anything that tells JUnit which code belongs to A and which tests belong to A, that's not very... I mean, we have that information probably somewhere in our code base, but it's not usable, really. Luckily, with Spring Modulith, we have. But given that once we have a change in A, we need to test A, what do we need to test if we find a change in C? A and C, correct, right? So that's kind of, it's not too hard. There's no need for like any kind of like very like AI analysis or what have you. It's like just math to some degree, right? So that's what you actually get. There's an Spring Modulith JUnit jar, which you put on your test class path. And that has a variety of means to detect changes. And it will know about the module structure. And then it can find out about which changes have been made, right, up here. So in this case, we're going to see that in the demo in a second. So we only change the inventory, and then we know that order is not depending on the inventory, so we don't have to actually execute the test case, right? Let me, rather show that in demo to you. I have to, I think, git YOLO that thing. Where is it? Terminal. There we go. So what's happening is if I mct maven clean test. So if I run these tests, then you see that like all of the tests are actually running. Oh, boy, there's even Docker involved, right? So there's quite a bit of stuff going on. This is an expected exception. Where was my start of my tests? Up here. So there's a default modification detector, which means that on your machine, we do slightly different things that what we can do in CI. But on your machine, we basically consider all the changes that you have not committed or not pushed to the tracking branch that you have. Right? So basically, the delta from what's remote to what you have on your machine is going into the diff detection. If we don't detect any kind of changes, we run all the tests because we think, okay, if someone wants to if someone checks out the system from Git and wants to basically run the build, they probably should run the tests, right? Let me just briefly, wait a second, where was I supposed to add the change? Wait a second. Yeah, there we go. So I think we need to go to let me briefly run the modularity tests, the documentation thing. Where is it? Here. We render the documentation, and then we find source Modulith docs, all docs, and we should see that the inventory depends on the order. So let's change something in inventory. It could be as trivial as adding a method. Foo void. Just like some arbitrary change, whatever. And then let's run the tests again. Right, and then we can scroll up. You see that went much faster, right? Wait a second, does that work? No. Just for me to better find oh boy. To find where was it? Here, right? So we start the thing again. We then say, that's byte buddy, yada yada, different topic. We're going to talk about that later today. So here we go and say we use the file modification detector, and then the emoji doesn't display right, but we find the change in the inventory, and then we actually get exactly what we saw on the slide before, right? So it's like the pause thing. So we skip the tests that are not affected. We will still run all the tests that are located in the root module, which is basically in the base package. So the modularity tests would still run. And I think I have that on the slides. If you change anything about the code base that we cannot actually reason about belonging to a certain module. So if you change a dependency in your POM XML, if you have a change in your POM XML, then we run all the tests because we don't know what the hell you did, right? As I said, tests only executed if they're either directly or indirectly affected by a change you made to the code base. And the most interesting probably is that, especially for large code bases, it's quite useful to actually have that optimization run in your CI environment, right? I've heard like tons of times that, oh, we're going to microservices because then we only need to run the tests that we need to run for, let's say, the inventory because that's a separate build and what have you. You can basically achieve the same with that kind of stuff. The input here would be there's some property in environment variable that you would hand the plugin the git char of the last successful build. There's like a GitHub Actions action that can actually find out about that thing and then bind that to an environment variable, and we would read that so that we can actually build the proper diff, right? So if you had a couple of pushes to your repository that do not, or that broke the build, then you would still, for the next push, you would get all the ones included, all the changes included. Right. 12 minutes left, I gotta hurry up. Event publication registry. So everything that you've seen as or until now was stuff that's basically surrounding your application, right? The application verification is run in tests. The documentation is created in tests. So up until now, we didn't really affect the runtime behavior of the application at all, right? So it's like Spring Modulith is a kind of a supporting project for your project, but it's not. It hasn't appeared in the runtime. There's another big feature of Spring Modulith, the so-called event publication registry, that helps you with the following scenario. So, if you, for those who are watching the recording or haven't been in the talk on Tuesday, go ahead, watch that or watch the recording online. There's a certain way of integrating functionality within Spring Modulith that we recommend when you integrate application modules, right? So in this case, we're talking about like some order completion going on here, and we did the primary state transition. The primary functionality is part of the checkout thing, and the inventory update is then triggered by publishing an application event that's consumed via an application module listener. That thing is worth a talk on its own, and as I said, there's plenty of that in the recording of the talk on Tuesday. But what's happening here is that the code on the left side commits. The event is triggering the method invocation after the transaction commit, and that thing is executed asynchronously. Right, so and that bears the risk. I mean, that helps for certain characteristics of your application architecture, but it bears the risks that the other thing fails and is not actually, you basically lose the information and you still have to update the inventory. So what's the feature that Spring Modulith offers to deal with that? It's that for every event listener or event, we kind of combine the pair of event and event listener to create an entry into the database within the original business transaction of a so-called event publication. Right? So when you publish the order completed event, we know there are like 2 or 3 listeners that want to actually be informed about that thing, and we write a log into the database. So we mark the event publication as published and processing, and then there is some decoration of the event listener going on, and that will eventually cause, when the event listener has done its work, to mark that event publication as completed, right? With that, or that means that even if the listener fails, you still have a track or a record of, oh, we still need to invoke that thing, right? Ultimately. And the original design was very like simplistic. We didn't know what you would do with it. What people, or let's say, okay, what do we do with the ones that have failed? In what kind of criteria do we select the event publications that have failed to resubmit them? There was API to do that, to resubmit the non-completed event publications, but it wasn't really sophisticated. And there's been a lot of great feedback from the community that, okay, this was kind of insufficient, which we kind of knew. But as if you watched Ian's talk yesterday, Ian Poetsma, a long-time Spring team member, said, if in doubt, leave it out, right? So we didn't want to like prematurely do something. But now that we've got the feedback, we have a solution to exactly these questions, right? So there was no way to distinguish between the failed event publications and the ones that are still processing. So most people applied some kind of like, oh, if this thing has been marked processing for 5 minutes, then it's probably failed, right? Resubmissions in multi-instance scenarios were a constant theme that were coming up. So people used things like scatlog or what have you to then trigger the resubmission. Still, people were using that in production, but it's like it was clear there's room for improvement. So what do we do with version 2.0? We not really completely rebuild it from scratch, but we basically, for one, separate the state of being published to the state of processing. We introduce a new state, explicit failed state, which is kind of just helpful to differentiate one from the other. And there's also, and that's actually approaching the second question here, there's an explicit resubmission state, right? So an event publication can be actively resubmitted, and only if an instance of your application can actually apply the state transition to resubmit it, it's also immediately sent to the event listener. That nicely covers the multi-instance scenario. So if you have like multiple instances of your application running and they're trying to resubmit the same event publications, only one of the two, thanks to like databases, will be able to actually perform the update in the database and then get the thing to processing again, right? So all of these state transitions, except the one from published to processing, or no, to publish, the original one, and the resubmission state transition, are actually taken care of from the application listener declaration. And you basically write code. I mean, for the first arrow, you don't have to do anything. You just publish the event, right? And the second thing is now can be triggered through a dedicated interface called failed event publications, and then you set up some criteria, how much you or how many of those you want to batch into the next resubmission execution and what have you, right? And the final thing we did is that we added a couple of more like low-level properties that or people have expressed to be interesting in that regard. So the number of completion attempts, right? If I have tried to resubmit an event for 10 times and it's not actually it still has failed, we can actually cause them to be skipped during resubmission, and also what are the last resubmission date is in a similar realm, right? Let me briefly check how many slides I still have to find out about. Oh boy, that's going to be tight. I guess I leave it for the demo. So because what we would go and see here was basically some code executing. Let me just show you that I had prepared a demo, and that demo is like also available in the Arc Evident Spring project. An order completed event with one listener talking to a Kafka, sending a message out to Kafka, and the other one deliberately designed to fail. And the first iteration of the test basically asserts that we have kept track of the failing event listener, and then it's issuing a resubmission attempt, and then the second time it succeeds. But we're going to leave it at that. With the events, with the state transitions going on, there of course is a risk, right? All these state transitions need database updates, and for some reason, in some of these state transitions, someone might pull the plug of your machine, and then that not necessarily happening, right? So what we also provide with the 2.0 version is so-called staleness monitor. It's a separate thread that's like that you can configure with certain properties, in which you define, after when I find an event publication that's been in the state published for more than a minute, then there's probably something wrong. The same for processing, for resubmitted, and what have you, right? So you can react to event publications getting stuck in a certain phase here. That's kind of the idea, right? And the staleness monitor would basically just flip them all to failed, and then your resubmission logic would just go ahead and handle those. Okay, the last thing actually is that there's been, and you've seen that for IntelliJ IDEA in the morning with Josh, with Josh's talk. There's like been dedicated support in IntelliJ IDEA for Spring Modulith, introduced in the 25.2 version. There's been a recent. That's basically what I wanted to show here, but due to the lack of time, there's another IDE called VS Code. Not sure if you've heard of that, which our tools team provides a functionality with, and there's been a prototype out that has the same or similar but slightly different approach to this, which shows that the application module structure and lets you browse the project in an, let's say, higher architecture level or design level approach, with like the individual modules listed here, and then the individual like design concepts applied in code listed as like, okay, here's all the controllers and configuration classes and what have you. Right, so check out. This is like in the latest in the pre-release version of the Spring Boot tools for VS Code. Is going to also be included in for Eclipse later on. The first prototype was done with VS Code. So, to summarize, nested application modules, propagating named interface declarations, that's stuff you've seen. I haven't had the time to show you the verification options thing. When you call application modules.verify, we actually apply a certain, like a variety of verifications. No cycles, no references to module internals, no field injection. Sorry about that. And we also, depending on if you're using some of these JMolecules libraries, which are these architectural and design language elements in code verifications, we automatically trigger those. And if you want to customize any of that, there's this new verification options parameter that you can hand into the method, and then also add any kind of ArcUnit rules that you might want to craft for your project. Right, so you can basically just include it. Change where test execution, test source beans, right? So if you have, let's say, integration tests that you want to, instead of a mock, you would want to just like have a test replacement of a repository. You can just declare those in a module in the package path that your module resides in, and then they would be picked up automatically. The documentation has seen a lot of like visibility improvements, meaning that the actual canvas only shows application events that are actually visible to other modules. So there's a more polished way of like differentiating internals from externals. I didn't show you the application modules file. It's like a JSON description of your modular arrangement, which can be helpful for some of the runtime features during Bootstrap, and also helps like tools like the Tanzu platform, like our deployment platforms, to actually allow your operating platform to inspect the modules, change log levels per module, and what have you. Yeah. I guess there's like, okay, verification on startup, this kind of stuff. And the observability stuff has been revamped, rewritten from scratch. And we automatically create metrics for events that cross module boundaries. That's kind of interesting, I think. You've seen the extended lifecycle in the status monitor and the tool integration. Just if I have one sentence, we're going to look, okay, this is like going to be 2.0. There's a lot of stuff, more stuff coming. We want to derive the same way that we derived like this documentation stuff that we have. We want to derive C4 DSL snippets for you to include into your C4 descriptions. Database migrations per module, something that I want to look into. Failure signals for module listeners, so that module listeners can actually send out an event in case they fail for whatever reason. So if they have, I don't know, catch an exception because they can't talk to the SMTP server, they could be throw in an event and then work from that. And of course, in the light of the use case that Jos mentioned this morning, it would be nice if we could just like in an existing application just say, oh, these are the current violations. We know about them, but we just don't want to introduce any new ones, and have something similar that ArcUnit has already built in. But as we do some extra stuff, it's going to be a bit of like more to do for us. And with that, I'll talk about hexagonal architecture later. So I'd be happy to see some of you back then. But until that, enjoy the rest of the conference, and thank you for your time.